G'day everyone, I'm Chris Bombolis. I'm your MC for today. On behalf of Workplace Health and Safety Queensland, welcome to our special Work Well presentation. I'd like to begin by acknowledging the traditional custodians of the land on which we meet today and pay my respects to their elders past, present and emerging. I'd like to extend that respect to Aboriginal and Torres Strait Islander peoples watching today. Just a little bit of housekeeping. If you have any technical problems, please make sure the sound on your computer is turned on and try refreshing your browser. If that doesn't work, contact us via the Q&A chat box on the right of your screen. You can also make this presentation full screen by selecting the 4 small arrows next to the volume bar at the bottom of your screen. It gives me great pleasure now to introduce today's speaker, Marion Burgess, who has been working in the area of workplace noise for many decades, including measuring worker noise exposure and research into noise control measures. Marion was appointed a member of the Order of Australia for significant service to science in the field of acoustics, particularly noise management, and to professional scientific organisations. Today, Marion will discuss the effects of high noise exposure and why it is essential to manage and protect workers from excessive noise. As noise-induced hearing loss is a preventable injury, she will also outline the advances in noise control measures that can be implemented in workplaces just like yours. Remember, if you do have any questions for Marion today, please type them into the Q&A chat box on the right of your screen. Well, that's enough noise from me. It's over to Marion Burgess AM.
Well, thank you very much for that very nice introduction. And I'm pleased to be able and honoured to be able to talk to the group of people who are involved with this this series of in this very important WorkSafe month. So as has been explained, I'll be talking about noise in the workplace, and I really want to stress that it will be an overview. There's no way that I can deal fully with noise in the workplace within a 1-hour seminar. I'll be very happy to answer any questions towards the end. So as was just mentioned, if there's something I say as I'm going through and you're a little bit puzzled about it, then please put a question into the chat box. Okay, so dealing with controlling noise in the workplace, in terms of my presentation, I'll be talking about, first off, sound and hearing, and then discuss a little bit the effects of high noise exposure, then talk about the hierarchy of control measures, and give a summary of various types of control measures that can be implemented in the workplace. And then finishing off with conclusion and, of course, any questions that you may have. So first off, to talk about sound and noise, we tend to throw around these two terms quite widely, and really it's just a description. So a sound, we use the word sound when we want to listen to sound, like music that we like to listen to, if you've had a long period without any rain, then the sound of rain on the roof is a very pleasant sound, and we refer to that as sound. Whereas what we don't want to listen to, we refer to as noise. So noise from noisy aircraft or from noisy jackhammers or various other activities in the workplace. But it's very important to remember that even if we want to listen to a sound, it can still be causing the same amount of damage in the hearing mechanism. So in terms of our hearing mechanism, there's really no difference between the two of them, because both sound and noise are essentially the same physical properties. That's the same sound wave coming into the hearing mechanism and going through into the ear. So just to give you an idea of some of the typical noise levels, this scale here starts at the threshold of hearing, which is the very quietest area. In order to try and get down to 0 decibels, then you've got to go through a really, really quiet area and have a specially insulated room, and then probably headphones on. So if anyone's had an audiometric or a hearing check, then they're probably getting pretty close to the threshold of hearing. But even in the quiet countryside, the noise levels are around about 30 decibels. Now, sound is measured in decibels, dB, which is a logarithmic unit. So as I just said, in a quiet countryside, it might be down around 30 decibels. Then in a busy office, it could be somewhere between 60 and 70 decibels. And the damage risk area comes in at around about 85 decibels. So there's 85, and then it continues on up higher to when we actually get to the threshold of pain. And that's where it's physically hurting your hearing mechanism to respond to this sound that's coming in through the ear. Another factor associated with the measurement of sound and the quantifying of sound level is that there's often a little A after the dB, a little uppercase A, and that refers to a frequency filter that is similar to the response of the human ear. And then sound levels that are measured with this frequency filter in it are referred to in dBA. So most of the guidelines associated with acceptable noise levels and hearing damage noise levels are generally given in terms of dBA, because that's the way we hear the sound. So, I've been talking about hearing. So how do we go about hearing sound? This is a section through the human ear, and really our ability to hear sound is a really complicated process. And we have airborne sound, which comes down through the ear canal, and then it strikes a little membrane, sets that membrane in vibration, and that then sets three little bones in vibration. And incidentally, as an aside, those three little bones are the three smallest bones in the human body. So that's actually a physical. So we have airborne sound coming down the ear canal, and then we have a physical vibration between that membrane through those three little bones through to another membrane. And then it goes into what is called the cochlea. And on the right-hand side of this screen, there's an extension of that part, which you can see the three little bones there vibrating. And then it goes into that vibration is transmitted into the cochlea, which is fluid-filled, has a membrane down the centre of it, and embedded in that membrane are a lot of hair cells. And that's where noise-induced hearing damage occurs. It's those hair cells. If they're made to move too much over too long a period, then they break away, and that means that part of the basilar membrane and that part of the hearing mechanism is not sending a signal through to the brain. So that's when it becomes permanent hearing damage, when you lose enough of those hair cells in different parts of the basilar membrane. So what are the factors associated with noise-induced hearing loss? Well, it develops gradually. It's not something that noise-induced hearing loss, it's not something that happens instantly. It's not like, you cut yourself with a knife or a saw or something, you can see the blood on the ground. With noise-induced hearing loss, it gradually comes upon you. So initially it's temporary hearing loss, and that's after an individual exposure or the first couple of noisy exposures in the workplace. If you've been to a noisy live music event or something, you come out of it and you've got a bit of ringing in your ears and it feels like there's a bit of cotton wool stuffed in your ears, and then a day or so later you feel that you've recovered your hearing. So that's what we call temporary hearing loss. It does cause a little bit of damage in the hearing mechanism, but not enough to really affect your normal lifestyle. However, if people are regularly exposed to high levels of noise over a period of time, then that leads to what we call permanent hearing loss. So it doesn't recover. So when they return home from work, it doesn't mean that they suddenly they can hear again. It's a permanent effect on their hearing mechanism. Another factor associated with it is that the sensitivity to noise-induced hearing loss does vary across the population, but we can't predict where somebody's going to be more sensitive or less sensitive to noise. So it's very important to protect all of the workers in the workplace and ensure that they're not exposed to excessively high noise level that's likely to cause noise-induced hearing loss. There's another factor that can come with high noise exposure, and that is a ringing in the ears. Now, it doesn't always come. Now, some people can have tinnitus without a great deal of noise-induced hearing loss. Some people can have tinnitus and hearing loss, and that's particularly debilitating because they have this ringing in the ears all the time, and then they're not able to hear clearly the information that they want to be able to hear. Hearing loss as such is measurable, and with audiometric checks or hearing checks, when you go along to an audiologist or a facility where they have a special test room and you put headphones on and sounds are produced and you identify with a little clicker what sound, when you can hear a sound, and that then gives a quantitative measure or an actual measure of the ability to understand and to respond to sound. Normally across the frequency range, if people have noise-induced hearing loss, there's usually a notch in the frequency range. And this normally comes in around about 4,000 hertz. Can be a bit higher than that, can be 6,000, 8,000, but it's quite identifiable as a noise-induced hearing loss because the performance just really drops off over a narrow band of frequencies. And this is it's very significant that it's happening here because that's where the hearing is most sensitive. So I referred earlier to the A weighting as a filter that's used in measuring sound, which is similar to the response of the human ear. And that highlights the fact that the human ear is not sensitive equally across the whole frequency range. The other difficult thing associated with this notch in the frequency response is that the important parts for speech intelligibility are actually in and around that range, not exactly 4,000 hertz, but over those higher frequencies. So that means that people with noise-induced hearing loss know somebody is talking to them, and they can hear the low-frequency sounds, which are predominantly the vowels, but they have difficulty interpreting the consonants, which have a lot of energy over this area where the hearing damage mainly occurs. So this slide here shows how noise-induced hearing loss develops over time, and you can see the blue line there, which shows the little notch that's occurring in their hearing ability after just 1 or 2 years of exposure to a high level of noise. And then gradually, as that time of exposure increases, then the depth of the notch and the broadness of that notch increases. So the person who's exposed to that particular noise for 15 to 19 years in this example, they'd be beginning to have difficulty understanding because they've got quite a loss around about that 4,000 hertz range. So they're beginning to have difficulty understanding what people are saying to them. They know they're saying something, but they're just not able to quite discriminate that what those words are. And then with continued exposure to noise, you get to the situation like that, the red line, the lower line on this chart, and that person there would have really quite extreme difficulty in understanding what people are saying. Of course, it's always possible to have a hearing aid, but if you've got a great chunk of the hearing response that has been damaged severely, like in the example of the red one there, it's really, really difficult to compensate for that with a hearing aid. So, hearing aids are not the solution to noise-induced hearing loss by any means. I'll just divert a little bit here because sometimes in the work health and safety domain, workers may respond and may comment about a noise in an area being, it's going to make me deaf. I'm really concerned about the noise in this area. And if you go and have some assessment of the noise made, you might find that it's below the damaging noise levels, but it's clearly causing annoyance to the workers who are in that area. It can cause disturbance, reduce their productivity, and of course, because they've got annoyed by it, then increase their stress. So a couple of examples: noisy air conditioners, a noisy compressor, traffic noise, aircraft noise, office machines, neighbours' music, etc. even though it's below the noise exposure or the really severe hearing damage noise levels, there is some guidance that's available for what are acceptable noise levels in a wide range of spaces, and these are related to the type of tasks people would be undertaking in those spaces. So I'll just give that as a reference. It's an Australian New Zealand Standard 2107, and it gives guidance on design sound levels for a wide range of spaces and can be used and referred to if there's a case where, having assessed the noise in the area, it's not actually an excessive noise, but it's certainly a noise that's causing annoyance to the personnel. You can compare against what the design sound levels for that sort of space is, and that then gives an idea of how much noise reduction needs to be provided. Okay, so returning now to a noise-induced hearing loss and protection of hearing, managing noise and preventing hearing loss in the workplace. Safe Work Australia introduced a code of practice which was adopted by the Commonwealth, states and territories, and fact sheets which summarise key points. And of course, Queensland Work Health and Safety introduced that code of practice, and it's continually being updated a little bit. This one is 2021 is the most recent one. There's little tweaks and little clarifications of certain aspects, but really the intent of the code of practice has remained the same since it was introduced. So the exposure standard for noise in relation to a person, it's very important, it's in relation to a person, is that the person should not be receiving an LAEQ over 8 hours of 85 dBA or an LC peak of greater than 140 dBc. So this is the exposure standard for noise, and as I mentioned, it's very important, it's related to the individual. So noise levels can be higher than that as long as it's not getting through to the individual's ear. So the intent is to prevent hearing loss. So the focus is on the head position, on where the ear is. So the LAEQ of 85 dBA is assessed very close to the ear. And that's really the guidance there. Now, I talked about noise levels earlier on. Now I'm talking about LAEQ. Well, the A is the frequency filter, which is similar to the response of the human ear. But what's this EQ and 8 hours? Well, that comes into the overall noise exposure during the total day, because people are not exposed to the same level of noise throughout their entire day. Some of the day they might be exposed to a higher level of noise, and other times of the day they might be exposed to a lower noise. So the equivalent energy level is an energy average over the 8-hour day, and that energy average for a person shouldn't be greater than 85 dBA. And this is just a chart to indicate and to highlight what this equivalent energy level is like. So the actual noise level could be going up and down as indicated on this chart, but the equivalent energy level is averaging that total energy that's in that time varying sound and averaging at that so that you get a single number at the end of the 8-hour calculation. Now, one of the aspects that comes out of this is that that you can be exposed to a higher level of noise and still have the equivalent energy level not exceeding 85 dBA, as long as the time period is not as long. So that then leads to what's generally referred to as a 3 dB rule, which says that you halve the time that the person can be exposed to a noise level above 85 dBA for each 3 dB increase in noise level. So this chart here indicates that 85 dBA at 8 hours, that's the beginning of the red line there, would have the similar effect on a person's hearing as 91 dBA for 2 hours. And then you can see as the noise level increases, the length of time that the person can be exposed to that sound level decreases dramatically. It's really important to realise that this 3 dB rule only applies as long as the rest of the day is not spent in a high level of noise. So saying someone can be exposed to a 91 dBA for 2 hours means that for the remainder of the day, they have to be in a much lower noise level, really in a quiet space. The time management of noise exposure is a very difficult thing to do in terms of the normal workplaces. But I'm mentioning it here because it is one control measure that I'll refer to a bit later on in this presentation. So what are the requirements in regard to noise management? The first thing that you have to do is identify the hazard. And this can be achieved by having a walk through and find out where you have to raise your voice to talk to someone, and that's potentially an area where the noise level may be in this excessive zone. Once you've identified where the hazard is likely to be, then you go to the next point and assess the risk, and this involves quantifying the noise levels. This can be done with the sound level meter to measure the noise level. And if you can see in the little image there, you can see the person is holding the sound level meter but holding the microphone close to the worker's ear to find out what the noise level is likely to be at that worker's ear. The other way of quantifying the noise is to use a dosimeter to measure the overall daily exposure. This small instrument is put on the worker and started at the beginning of the workday. At the end of the workday, it's stopped, and then you have a measure of what the noise level exposure for that worker has been throughout the day. There are advantages and disadvantages in both methods. Obviously, the sound level meter methodology is a little bit intrusive in the workplace. The dosimeter, the problem there, of course, is that you've got the worker wearing this little device throughout the day. Very easy for it to be bumped and very easy for other people to come up and shout into it. So one has to be very careful with interpreting the data from the dosimeter, just as well as much as one has to be careful about ensuring that you're understanding how you're using a sound level meter. So as I said, there are advantages and disadvantages in both methods. So then once the noise has been assessed, you have an indication of what the noise levels in those areas are. Next steps are to try and manage that noise. And the hierarchy of noise of any sort of hazard control, of course, is to try and reduce it at the source. So trying to reduce the noise at the source is the first approach and the first consideration. The next one is to try and reduce the noise transmission from the source to the worker. And then you try and reduce the noise exposure at the worker themselves. As well as that, you need to provide training so everyone understands what sort of noise measurements and noise measures are in place, what they need to be careful about, and how they need to understand what the noise environment is and what the noise management procedures are. Also, there's a requirement for hearing checks so that you're monitoring their individual hearing. Now, that's not a control measure, but it certainly is important because it allows you to identify a small hearing loss and then investigate why. If all your measures are implemented properly, then people should not be experiencing hearing loss. So if they are experiencing hearing loss, it's a time to really review what the measures are. And it's better to find that out sooner rather than later. And then, of course, you have to regularly review both the workplace and review the various measures that are in place to ensure that they're still being effective. So looking at reducing the noise at the source, eliminating the risk, try and change the method. Are there less noisy ways of doing the same work? And the mantra of buy quiet. If there's, at the time of procurement of new machinery, new instrumentation, it's really important to include noise in the performance specifications. And it's made easier these days because most of the equipment has to include or should include on their specifications or should declare on their specifications noise levels. This is an outcome of various machinery directives in the EU and also the manufacturers, once they had to start declaring the noise levels, they put extra effort into looking at ways that they can declare a lower noise level, and in fact newer instrumentation, newer equipment, newer machinery usually has a lot lower noise levels than equipment and machinery that's been around for some years. So in the machinery specifications, there, as I'm saying, there really should be some indication of what the noise levels are. But you have to be really careful about interpreting these. They should be measured by a defined procedure, and there could be two types of measures given on the specifications. One of them could be the sound power level, and the sound power level is a measure of how much sound is coming out of the machine. This is aimed at because the machinery specifier and the machinery manufacturer doesn't really understand where that particular machine is going to be placed, or doesn't necessarily know how far away the different workers will be from that machine. So sound power, with knowledge of the sound power and the acoustic characteristics of the environment and the distance to the worker, it's possible to estimate what the sound pressure level will be at the worker's ear. So that's one measure that can be in the specifications and can be declared. And the other one that can be declared is a sound pressure level, but at a particular point, because sound pressure level will vary as you move away from the sound source. Sound power is inherent in the source, but of course if you're very close to it, you'll get a very high sound pressure level. It'll sound very loud. If you're 100 metres away from it, it won't sound so loud. That is, the sound pressure level will be lower. So I've got two examples here just grabbed from some construction work declared values, specifications with their declared value. And one of the items just said noise 95 dBA. It hasn't said where it's 95 dBA. It hasn't said how the 95 dBA was measured. The lower extract there is from another type of equipment where they've not only given sound, but they've also given vibration levels. But focusing on the second line there, it said the sound power level, and they've got an indication there of the actual methodology that was used, the 2000/14/EC, which defined a method for measuring the sound power level. And they're saying that sound power level is 108. LW refers to sound power level. But they've also given the sound pressure level under an ISO 11203 measurement procedure, and they've said that the sound pressure level is 94 dB at 1 metre. So you've got very clear information there. If the operator is going to be at 1 metre from the sound source, then their likely noise level that they'll be receiving at their ear is 94 dB. If the operator is going to be at 100 metres from the sound source, then it's possible to calculate what that, or to estimate what that would be. Obviously, it'll be a lot lower than 94. So that specification there clearly gives a lot of guidance to how loud that noise is going to be at the operator's ear. You can change the method of doing it. As I mentioned, manufacturers continue to develop new methodologies. They continue to look at their equipment in terms of reducing a lot of aspects, the vibration aspects and also the noise aspects. A couple of simple examples are that air blades can be used in high-pressure air jets, pushing a high-pressure air out through a little jet. It causes a lot of noise. Because of the extra turbulence, and the air blades spread that turbulence over a greater area, and therefore the noise levels are lower. And yet they can still achieve the same goal of drying or clearing out areas. Electric-powered wrenches in place of the old-style rattle gun. The old-style rattle guns are using brute force to actually get the nuts off the bolts. A concrete crusher in case of a breaker. You get a breaker goes in and they're banging away at the concrete. A concrete crusher they're like the teeth of a parrot. They sort of crush into it and scrunch it up. So they're applying force, but applying it a different way. They're not applying it in an impact way. They're applying it in a more continuous way, and they achieve the same goal at the outcome. So, looking at a change of methods is it's a possible way of reducing the noise level for the workers in the area. Then we come to engineering methods. Let's think about the simple methods first before we get into that. Try and move the people or the source. Is it possible to make a change in the workplace? If you can move the people away, then the noise level is going to be lower. If you can move the source into a different space, then that can have a significant reduction in the overall noise level. Good maintenance of equipment. If a well-maintained item is working, then the noise levels are generally lower than if it's kind of, hasn't had a good service for a while, and it gets some of the aspects of it get out of balance, and you get a few extra knocks and etc. All of that can lead to higher noise levels. Equipment should be trying to operate within their optimum range. If you're trying to drive something at the top of its range, then it's usually not very happy at that condition. Its maintenance is going to need much more regular maintenance, and it's also going to be producing a lot more noise during its operation. I did refer to air jets on the previous slide. There are little air silencers that can be used on top of the pneumatic air jets to try and reduce that amount of turbulence, and that can also then subsequently reduce the noise. Vibration isolation, because what happens if you've got machinery, the vibrations go down in the floor or the surroundings can vibrate, and that then produces more sound. So isolating the machinery from the floor can can in many cases reduce the overall noise that's being produced. And another very simple method is to try and cushion the dropping of metal. Dropping metal onto metal or onto hard surfaces produces a lot of noise. So think about whether it's possible to put some sort of cushioning material. There's a lot of new products that are available that will withstand the impacts from metal or stone or those sorts of items dropping down onto them and last for quite a while. So it's very important to consider the whole system. If, for example, cutting steel with a shear, of course there's the cutting noise if you're going through the shear, with the shear going through the metal, I should say. But not only is that one noise source, but it's also what happens to the cut sheet. If it's loosely vibrating, then that vibration of the cut sheet can go through to the cutting table, which can then radiate more noise for the people who are in the area. So it's really important to consider the whole system, not just single items within it. One other method of dealing with noise is to have enclosures. Important things about enclosures is that you need to seal all the gaps. If there's a small gap that air can get through, well, then noise is going to get through that as well. The panels of the enclosure need to be well sealed to whatever the framework is. Usually you've got to have some sort of penetrations into an enclosure for electrics or hydraulics. Those penetrations have to be well sealed so that only the cable or the piping goes through. You need to have well-designed maintenance access panels so people can get in and do the maintenance that's necessary and then close that panel off. And then you get back to a good, well-sealed enclosure. If you've got to get air in and out, which is often the case, to cooling air in and out to some sort of machine, then you need to include silencers on the ventilation inlets and outlets, because as I just mentioned, any direct opening for air is going to let through quite a bit of sound as well. If you've got to get product in and out, then you actually got another challenge in that you need to have some sort of special treatment for the product inlet and outlets, because trying to minimise the open space there, trying to minimise the amount of sound that's going to escape from the enclosure as the product is going in and going out. Another aspect of enclosures is to line them internally, and that helps to reduce the build-up of sound within the enclosure. These are just a couple of examples of enclosures. The upper one really shows that if you've got rather a complicated system, you can have multiple enclosures. So there's an enclosure part of the system on the left-hand side, and then another part of the enclosure for the main part of the operating system there on the right-hand side. And the lower one is a more solid enclosure around a compressor. Another aspect of reducing the noise is between the noise source and the receiver or the worker. Distance is very effective for those who are very close to the noise source, because the way the sound reduces with distance is based on inverse square law, which means that as you double the distance, there's the same reduction. So if you go from 1 metre to 2 metres, you get the same amount of reduction as if you're going from 100 metres to 200 metres. So for people who are very close to the sound source, moving from 1 metre to 2 metres can give a good reduction of sound. But if people are already 10 metres away from it, then they've got to move a long way to get the same level of reduction. So distance alone is mainly focused on trying to keep people who don't need to be near the noise source away from the noise source. Screening is another way of reducing the transmission of sound between the noise source and the worker. Screening and putting something in a separate room is an ideal way, and then you've got a very large enclosure, and that you've got the whole room as an enclosure around the noise source. That's a great way of dealing with a noisy situation. There are also possibilities to have temporary and portable screens. These need to be designed so that they're long enough and high enough, and they partially enclose the noise source. The one on the left-hand side of the screen there is a reasonably fixed one, but it can be moved around. So it's lightweight, it can be moved around, it can be pulled out as necessary and then pushed away when the noise, if there's only an intermittent noise problem. The one on the right is a bit hard to see the screen there because it's a transparent screen, but I'm showing that because it's quite a tall one. It's hanging from the gantry at the top of the panels there, and it's completely enclosing an area, but because it's transparent, you can see what's going on inside that area, and when there's a need for people or products to move through to that area, the whole screen is flexible plastic. It can be moved back, and the product can be moved in and out, etc. So there are a number of options in terms of either having temporary or portable screens that can be quite effective in a workplace. Many people have heard about active noise control, and traditionally the most common way of coming across active noise control, of course, is the headphones that you can use to listen to music when you're in a noisy area, usually inside the cabin of a plane. Active noise control can be used for noise control in the workplace. It's a lot more challenging though. What you're doing with active noise control is generating sound that's 180 degrees out of phase with the noise itself. So active noise control is more efficient at low frequencies. You do need many transducers, that's many microphones and many transducers that are producing the sound 180 degrees out of phase. Very difficult to do it over large areas. And there are some solutions around that are using active noise control, but they're really developed on a case-by-case solution. So while active noise control offers great benefits, particularly in industry because it's more efficient at low frequencies, it's quite challenging still to apply it in many, many workplaces. So that then leads, we've dealt with controlling sound at the noise at the source, controlling noise between the source and the receiver. The next one is controlling the noise at the worker themselves. So that's trying to reduce the noise at the worker. So I mentioned distance, and I did highlighted the fact that distance, simply moving people a little bit away from the sound source is quite effective if they're quite close to the source. But in a more general workplace where people are at medium and further distances from the sound source, then moving the worker to a quiet refuge is a very effective way of trying to reduce their noise exposure. Putting sound absorption around in the workplace is more effective for the distant workers. It's not going to help the worker who's exposed to the direct sound from a machine or an item of equipment. but it certainly can help to reduce the noise that's generally around in the workshop or the work area. So sound absorption is more effective for distant workers, but if somebody is relatively close to the noise source, then they're getting the direct sound, and the sound absorbing materials is not going to reduce that very much at all. You can try and reduce the time people are exposed to. I referred to that earlier in this presentation where I said there's that 3 dB rule. Very important though that if you are going to use the reduction of time, that you make sure that the worker really does spend the rest of the day in a quiet space. And it's often very difficult to manage that, that specific short amount of time in the high noise area and then the rest of the day in a very, very quiet space. The last resort is personal hearing protection, and it can be temporary while you're finding other solutions, and its long-term use is considered as a last resort. However, it is available, it is used quite widely in workplaces, and it really is it is one way of trying to ensure protection for the workers. There's a very wide range of hearing protectors available. You've got ear muffs, ear plugs, ear canal caps, acoustic helmets, and then there are special types, level-dependent active noise reduction and communication headsets. It's important to ensure that, that the right type of protector is selected for use in the appropriate area. If we talk about hearing protectors, that's ear muffs to start off with, then ear muffs by themselves are considered as a passive. You just put them over the ears. The heavier and tighter the clamping, the better for the performance. Therefore, as you can imagine, helmet-mounted earmuffs or even the earmuffs that are on a strap that go around the back of the neck because the person has a lot of other PPE that they're wearing, they're not going to have such a good clamping force over the ear, and they usually have a lower performance because of that reduced clamping force. Electronic passive, these are earmuffs that normally are giving passive protection. So they're useful in an area where people are exposed to noise most of the time, and then on occasions they need to have some sort of communication. When they need to have communication, there's a little button on the side of the cup, and they push the button down, and there's a microphone on the outside, a little loudspeaker on the inside of the cup, and they can listen to the speech or the instructions, and then they can release their finger from the press button, and it shuts down after 30 seconds. And then they're back to the normal passive protection in that particular workspace. So that has application when there is a need for intermittent communication, but there's generally a fair bit of noise around all the time. There's another type of hearing protector, which is a similar name, but is called electronic active. And this is when there's generally a low level of noise most of the time, and then on occasion there are high levels of noise. And a classic situation where this might be the case is, say, at a shooting range, where a large amount of the time the instructor is telling people what to do and how to line up their guns or whatever it is that they're doing. And then once they start firing, there's quite a lot of noise. So electronic active has a microphone on the outside, a little loudspeaker on the inside, and it allows people to hear what's happening when the level is low. But as soon as the level goes above a particular preset level in the earmuff system, then that connection between the microphone and the loudspeaker on the inside of the cup is shut down, and then you get the passive protection of the cup itself. So they're used in the opposite scenario to the ones where the electronic passive ones might be available. Electronic active is used generally when a lot of the time the noise level is low, and there's only short periods of time when the noise level is excessively high. And there are options for including communications in those types of headsets. Earplugs, a variety of earplugs around. Most of them you roll down or you squeeze up and push into the ear canal. The ones that are pre-shaped, and they generally have a lower performance than the roll down and push into your ear canal. It's a matter of choosing the most applicable hearing protectors or earplugs for the particular work environment. There's always a problem with hearing protection and communication. Concern about, well, if I'm wearing this hearing protection, I won't be able to hear warning signals, I won't be able to talk to colleagues, etc. Modern signal processing and miniature electronics have led to quite a few more options, and one of those is this the Senseer, which is one innovation that uses analysis processes to extract speech signal from noise. And it also allows for communication and Bluetooth channels and mobile phones. So there's quite a range of options out there. We're not all stuck with just the passive hearing protection. We have quite a range of alternative types of PPE that can be used in a wider range of workplaces. Hearing checks, that's part of the overall program. It's a tool for managing the risk of hearing. The guidance is that tests should be done within 3 months of commencement of working, and then at two yearly intervals for people who are in noisy work environments. People who are in high-risk groups, and particularly noisy environments, may need more regular testing than that. It can supplement noise training because it's an ideal time to have a little bit of additional training on the noise measures that are in place in the workplace, because if there is a very small drop in the person's hearing, then they're more aware about noise and the fact that they've really got to protect their hearing, and then it's a good time then to supplement the hearing check data at the same time as the noise training happens. So there's a lot of information available. I've just got a few web pages there, the code of practice and information from the Queensland WorkSafe website, additional guidance from Safe Work Australia website, and there's some really good information on various types of solutions and case studies from the Health and Safety Executive in the UK. So that website there, you can follow through and find their sound solutions, and they've got a lot of good examples, practical methodologies for trying to reduce noise in a wide range of workplaces. So, in conclusion, high noise exposure will lead to permanent hearing loss over time, but it is preventable. Noise management programs include identifying the areas and measuring the noise so that you quantify it, assessing the risk to hearing, implementing appropriate noise control measures, providing training for the workers, providing hearing tests, and of course reviewing the control measures on a regular basis to ensure that they're all working as they should be. So, thank you very much for your attention, and I'm very happy to answer any questions that might have been put into the chat box.
Thanks, Marion. We've had lots of positive feedback about what people are describing as a very informative presentation, so congratulations on that. Let's get into the questions, and I can see there's at least half a dozen of those. Firstly, from Rosalind, and Rosalind asks, if workers do complain about noise in an area, but it is below the workplace noise limit of 85 dBA, what would you suggest?
The first thing I would suggest is to see whether there is any way that you can reduce that noise in that area. Is it possible that there's something there that's producing noise at maybe 75 dBA, which is just really annoying the people there, and is it possible to move that? So you can use the same sort of techniques as you would use for excessive noise, distance, enclosures, or things like that. And then the next, if it's not possible, then the next line of attack is to provide personal hearing protection, which has a very low performance. I did mention that preformed hearing protectors generally, preformed earplugs, etc., they generally have a lower performance, so you can get some little ear canal caps that just sit over the ear canal and they reduce the noise by about 10 dB, something like that. They don't have to be pushed into the ear. And that can provide a bit of relief for people who have to be working in an area where the noise levels are around about 75 dB, and you've tried other techniques and there's no other option for it. Then that can provide a bit of relief and reduce their stress in that situation.
Okay, very sound advice. Anne, thank you for joining us. Anne wants to know, what equipment or tools do you recommend to test workplace noise? Do you think that phone apps or smartwatches with hearing register apps are the same standard as, say, handheld equipment?
No. Apps on phones can be very helpful in that first walk through. I referred to walking through and just finding out whether you can talk comfortably to colleagues in an area. That's one way of doing it, but if you have an app, you can get an indication, a rough indication. A couple of problems with apps in that the noise levels are provided, but often they're not providing it in the same metric or the LAEQ values that are as easy enough to transfer. And remember, I mentioned about the dBA. Often they don't have the A weighting in them, so you have to be really careful that the data that you're getting off the app is actually using the same metrics as that we're using when we're talking about the noise exposure limits. The other major problem with apps is that they're quite difficult to calibrate. The app, so many different, if you just take Android phones, there's so many different types of Android phones around, and then you're getting an app which is you're downloading to an Android phone, and some Android phones have the microphone at one position, some of them have in a different position. You've got to be really careful about where you're holding it, etc. So, and then if you try to calibrate it, the calibration methodology, there's no calibrator that you can put on it, there's nothing that you can really check that it's responding accurately. So my answer to that is that they're good to try and get a general indication of whether there's likely to be a noise problem in that area. They can give you like a ballpark figure, but beyond that, no. In order to properly assess the noise in the workplace and properly select the most appropriate noise mitigation measures, you really do need to have a proper instrument to do it.
Isla also joined us, so thank you, Isla. And Marion, she asks, there are two limits in the standard and one is for the LC peak. Can you explain a little more about what this is?
The LC peak is for impulse noise. So this is when there's a very short, sharp rise time in the sound. So it's just like firing a gun, or those ramset guns that they use in the building industry. Just doing one of those is a short, sharp rise, or a press if you're in a heavy engineering area. A shear press might cut straight down through a sheet of metal, and that's producing an impulse noise. 140 dBc, and that's slightly different weighting, and that's because of the nature of the impulse noise. It has a very sharp rise time and a very sharp drop-off time, and that 140 dBc limit needs a lot of energy in it to actually achieve that value. So most short duration sounds that happen in industry, the majority of them are well below 140 dBc. So they're not likely to trigger that limit. The sorts of sounds that are likely to trigger that limit, I think, are ones that, like I referred to, ramset guns. If they've got one of those little explosives in them, then they would, the higher value explosives, they can exceed 140 dBc. A very heavy shear press can exceed 140 dBc. But there's needs maybe scaffolding too, and in that case, there's the bang of the whatever tool they're using against the tube of the scaffolding. Depending upon the length of that tube and the way it's fixed, it can resonate in such a way that it can actually produce a noise level approaching 140 dBc. But the other area where it's likely to be exceeded is in anything to do with firing pistols, rifles, etc. So majority of industry is unlikely to exceed 140 dBc.
This one comes from Wendy. Is it a dosimeter? Yeah, seems the easiest way to obtain information, pardon my pronunciation, on noise exposure. So why do you also suggest using a sound level meter?
Yeah, and it doesn't really matter which way you pronounce it. To be honest, I alternate between them myself. The challenge with the dosimeter is that you're putting it on the worker, and you're relying on them being aware that it's monitoring the noise, but then you don't want them to be too aware that that you're monitoring the noise. So you don't want them to change their methodology of work. You don't want them to change. You don't want them to have people coming up and talking into it. You've got the case of when they might be changing. They might want to put a jumper on, put a jumper off. Very subject to bumps and thumps, etc. The other thing is that unless you're watching what the worker is doing during the day, you're relying on them reporting to you what it is that they did during the day. So you might find that the noise level is quite high between 11 and 12. So you have to ask them, well, what were you doing between 11 and 12? And then it's often hard for them because they haven't kept a very accurate diary, etc. So it's certainly a good way of identifying whether there are particular noisy time periods during the day. It's certainly very good for people who have to go into confined areas where you can't walk along with the sound level meter, you can't follow them. It's certainly applicable for checking on a regular basis, but in terms of the proper noise survey, the sound level meter is giving you more information about the actual noise exposure that the individual's getting for that particular operation of that tool in that workplace. And from that, you can then develop the noise management procedures. So I think if just in summary of what I've just been saying, the sound level meter is very good for the initial noise survey through the workplace, and then you supplement that with the dosimeter information. And then you can just use dosimeters into the future to check that everything's going along quite smoothly and quietly.
Thanks for that, Marion. From Robin, hearing loss is the main injury associated with a noisy workplace. Robin says she's seen studies of the impact of noise on ECG and increasing the risk of heart attack before hearing loss may even occur. Are there newer or better ways to monitor the impact of noise on worker health?
She's talking about more broadly the overall effect of noise on the individual. Of course, this is an issue of great concern because we're exposed to lower levels of noise as part of our normal daily life, getting on trains, transportation noise, environmental noise, etc. All of these noises can lead to stresses if we're annoyed by them, if we're annoyed by aircraft overflights, if we're annoyed by the noisy truck going down the road, etc. So from the environmental noise point of view, there have been quite a few studies on investigating the health effects, the non-auditory effects of noise, and there certainly have been studies that have shown that there are various effects that can be measured in certain communities, and that then helps to establish what the acceptable noise levels for environmental noise are likely to be. So any noise in any area that's likely to be annoying is likely to increase your stress levels, which is likely to have in the longer term perhaps some sorts of health effects. But really that's not my area to say too much more than that.
Okay, and as time is on the wing, let's wrap it up with one final question from John. John wants to get a tip from you, basically, about getting older staff to buy into wearing hearing protection.
Yes, interesting that he said that because, yes, it does seem that younger people are more accepting of wearing hearing protection than some of the older people who've been around for a while. There's a common thought that, I've already lost a lot of my hearing, it's not going to, I can't lose too much more. Well, in fact, they can because it's going to be even more rapid their hearing loss. So I can only think that motivation and also doing training at the time of having the hearing checks is really good strategy, because they can see what their hearing loss is, and then really reinforcing how important it is to wear hearing protection while they're doing the noisy task to maintain their hearing. It's not going to help, they're not going to improve their hearing, but at least it will maintain whatever hearing that they have.
Thanks again, Marion. Great advice. And again, thank you for joining us today for a very special presentation.
You're welcome.
Thanks everyone for joining us as well. Hope you enjoyed it. Before you go though, I need a favour. We'd love to hear from you and get your feedback on today's presentation. So please grab your phone and scan the QR code on the screen to take a short survey. It'll only take a couple of minutes, and we really do appreciate your input. It helps us formulate presentations like these for the future. Key takeaways from Marion's presentation will be available on worksafe.qld.gov.au in the coming days, along with her presentation. You can also re-watch the session today on the Watch Live link you are using right now if you are eager to catch up or replay ASAP. And while we're on the website, check out our full range of case studies, podcasts, speaker recordings, webinars and films to help you take action to improve your WHS and return to work outcomes. These resources are free to download, so I would encourage you all to share them with your staff and your networks. Thanks again for joining us for this very special Work Well presentation. On behalf of Workplace Health and Safety Queensland, remember, work safe, home safe. Bye for now.